Okay, so this is the master MATLAB script that was used to perform the sensitivity analysis for the bottle rocket competition. So you'll see here we have the launch a rocket rev 2 script, and this script relies on 4 other scripts to function. First we have set inputs rocket.m. This is the script where we enter our initial conditions and our physical constants. So you see here we have our constants like our water mass and gravitational acceleration. And over up here we have our constants, our physical parameters for our vehicle that we can tune. So we can set the structural mass, the payload mass, and the coefficient of drag. Now the main simulation happens in these 3 scripts. The first one being FE rocket, which computes the force at every given time. Then the calc F rocket function and the simulate rocket function work together to compute the distance traveled at each time step, and then sums up those distances traveled to obtain a large matrix consisting of all the time steps in the output, which we'll see here in Launch a Rocket Rev 2. This output is over here in Launch Rocket Rev 2, and you can see how we keep track of the x distance, y distance, z distance, mass of water, and the time. So the modifications to the launch rocket script were made in order to compute the maximum distance traveled and then the corresponding water mass and launch angle required to hit that distance. So essentially, the script consists of a nested for loop that iterates over all the possible water masses from 0 to 2 kilograms in steps of 50 grams, and all the possible launch angles in steps of 1 degree from 0 to 90 degrees. For each step, we calculate the maximum distance traveled by running the launch rocket simulation with those initial conditions, and we generate a 3600 point multivariable plot that we plot using the scatter function. And an example of one of these plots is given over here on the left. So we'll open up a basic baseline design. This is with the baseline CD and the baseline structural mass. So here in this graph you can see the initial water mass plotted on this axis and the initial launch angle plotted on this axis, with the resultant distance traveled for each data point plotted on the z-axis. We can rotate it around here to get a little bit better look, but you can see that the initial water mass for optimum distance lines up at about 800 grams of water, right about here. And the switching over to the launch angle axis, the optimum launch angle lines up at about 44 degrees for this particular trial. So after taking a look at this graph, we can switch on over to the Launch a Rocket tab, and where you can see how we output the distance traveled as a function of water mass and launch angle. So for the sensitivity analysis, the coefficient of drag and structural mass parameters were changed, and they were changed over here in the set inputs rocket.m tab. So over here we varied the data.ms and data.cd. We varied those from 100% to 90% of their original value, and then we had 4 trials, one with baseline CD, baseline MS, 90% CD, baseline MS, 90% CD, and 90% CD, 90% MS. After setting the initial conditions for each test, the launcher rocket script was run to determine the optimum water mass and launch angle, as well as the maximum distance for that given combination of inputs. The inputs were graphed, and then the results are available on the slides.